Good morning, good afternoon, good evening, and welcome to another episode of OpenShift TV. I am Chris Short, executive producer of OpenShift TV, and I am here with two of my favorite red hatters. I just met them. Let's talk about Fedora CoreOS is our topic today, or FCOS as we might refer to it. Clement and Timothée are here, and I'd like them to introduce themselves because I'm terrible at introducing people. So Clement, you want to go first, just alphabetical order-wise?
Yeah, so I'm Clement Verna. I'm engineering manager at Red Hat with the CoreOS team, and I've been a Fedora contributor for maybe 5 years now. So involved mostly in the infrastructure, and also I'm in the Fedora engineering steering committee, FCOS, so looking after changes and what is the future of Fedora. So that's about me. Timothée, you want to go next?
Sure. So hi, I'm Timothée Ravier, and I'm part of the CoreOS team too. I work on Red Hat CoreOS and Fedora CoreOS. And I'm also the Fedora Kinoite maintainer on Fedora, so which is like a kiddie variant of Fedora Silverblue. And yeah, I'm doing most things in Fedora right now and around that.
Awesome. So what is Fedora CoreOS? What is the goal of the operating system, right? Like all those fun things. Tell me more.
Good question. So we got a small presentation that I think I'll share with you, just to kind of like Fedora CoreOS, the basics, one-on-one. And I think that will hopefully at the end of this presentation, you will have a good idea of what is it, what are the goals, and how you can start playing with it. So as you said in the agenda, we are like, so yeah, what is Fedora CoreOS? What are some of the features? How it relates to RHEL CoreOS, and also the relationship with OKD. And we have at the end we have like a small demonstration on how you can use Fedora CoreOS to deploy a matrix server at home. And we will have time, obviously, for questions.
Obviously, yes. And please feel free to ask questions or comment or anything during the presentation. And if there's a good spot for me to ask it, I will, or we'll ask it at the end. Regardless, your question will get answered.
Yeah, don't hesitate to interrupt. I think it's nice to get the question as they come with the context.
Definitely.
So Fedora CoreOS is currently an emerging Fedora edition. We're trying to become a fully pledged Fedora edition. But currently, it's with the emerging status. So it came from like the merging of the CoreOS, the company Container Linux, and a project that was in Fedora, Project Atomics. Pretty much it's trying to look at what would be like a specialized operating system dedicated to run containers. So Fedora CoreOS incorporates pretty much from the Container Linux, the philosophy, the provisioning stack, and also a lot of the cloud native experience that was in the CoreOS company. From the Atomic host, it gets all the ecosystem from Fedora, so the Fedora Foundation, like all the community aspect, the update stack, and also it comes with SE Linux and all the experience on like SE Linux hardening and the security on that.
Awesome.
So if we look at the philosophy behind Container Linux, like probably one of the most important is automatic update. You want your operating system to update automatically and not have any need for an administrator to log in and run commands. That's quite important from like a security point of view. We see, so you're always up to date. You have like the security fixes, CVEs fixed and everything. You want a way to provision your nodes and servers using pretty much they all start from the same point and they all live they all have like a common definition and like a way to provision them. And you have like the same method for bare metal or cloud-based. So you can have like a mix of instances in your infrastructure. Yeah, everything, the immutable infrastructure. So yeah, if you need to change, you update your config and you reprovision. So those hosts are like are very easy to just destroy and reprovision. And the main point is that everything that is like a user software or like workload or like everything that you want to run on those operating system has to run in containers. So which makes the host like much smaller and also the updates much more reliable.
Awesome.
So let's go through like some of those the main features related to the philosophy that we just looked at. So yeah, automatic updates is probably a very important one. So to be able to achieve that, you obviously want your updates to be reliable. If you offer automatic updates and they break all the time, people will just like disable them. So the real focus of the project is to make sure that we provide reliable updates, and we make sure that when your operating system updates, it doesn't break. So to do this, we have we rely extensively on CI, and we're doing a lot of tests there. We're testing also on different platforms, on different clouds. So currently, like for example, AWS, Google Cloud. We're also testing with OpenStack. We have a system of release streams that enable us to push like changes to different streams and be able to catch like regression or to catch breaking changes early, so it doesn't come to the stable stream. So we have 3 streams: stable, testing, and next. We'll go into more details after that.
Nice.
And another key point is that there is managed rollouts of updates. So the updates will be rolled out over several days. So if you have a fleet of Fedora CoreOS nodes, you can maybe have like a couple nodes to try to update early, and the rest of your fleet to update at the end of the rollout. So you can kind of do some early testing on 1 or 2 nodes and like protect the rest of your infrastructure. So having this also enables us to stop or alter rollout. So if we got reports from something breaking, it's fairly easy to just stop the update rollout and not impact too many people. And yeah, if things go wrong, we rely on the RPM OS 3 technology that we will talk about just after. And it's very easy to roll back to the previous working state. So even if at one point your operating system is in a state that is not working or that broke, you can roll back to the previous working state. There is some work that will be done in the future to try to automate that rollback. So trying to have users specify some health checks and make sure that when the operating system reboots with a latest update, making sure that those health checks are green and just continue. And if they are red, you would just roll back to the previous state. So yeah, a bit more information on the update streams. So as I was saying, we got like those 3 streams: next, testing, and stable. And next is pretty much the latest, freshest. It's also where every major Fedora rebases happens. Testing is it's a preview of what's going to stable, and it's pretty much where we're trying to catch any breaking changes that we didn't catch in CI. And stable is where we want to offer this like reliable experience where you can just stay there and be happy and let your node update themselves like without worrying too much. So yeah, how it works is that pretty much the content that is in testing stays in testing for 2 weeks, and after this 2 weeks period where we can have like feedback, it will get promoted to stable. So the content that is pushed to stable usually is very well tested. So here it's written that we have the goal to publish new releases every 2 weeks. I believe we are able to achieve that goal. We release every 2 weeks on a regular basis since more than a year now. And yeah, the stream, next, and testing are really where we try to catch any issues or like get kind of the real life testing, and rely also on users to report problems that they have.
Awesome.
So you can like decode the version of Fedora CoreOS and kind of have an idea of what you're running. So that just a quick slide to explain that, but pretty much in the version you have like at the beginning 31, 32, 33, that would be the main version of Fedora, so the base. Then you have the date at which the snapshot of the RPMs was done. So at this particular date, we just took whichever RPM version were available in Fedora. And then you have like the release stream. So 1 for next, 2 for testing, and 3 for stable, and then the revision. So yeah, you got here the diagram that explains this like 2 weeks promotion and how the content is propagated through each streams. Do you have any question on this yet? Or?
I mean, there's a lot of questions about like what was the origins of Atomic, right? Like where did that come from? How did that start? All the way up to how is CentOS Streams related to Fedora CoreOS, if at all? So I mean, let's just run through the basics there.
Yeah. I think really in terms of Atomic, it was really linked to RPM-OS 3 also, and like trying to have pretty much having this idea of having a very small like operating system with all the core application that you need, and be able to run any user application or any software using containers. So a lot of the philosophy between Atomic and CoreOS were shared. And when Red Hat bought CoreOS company, I think it made a lot of sense to have those two projects to work together.
So it's safe to say that Fedora CoreOS is pretty fast moving, right? With 2 week releases and everything, right? Like you're pacing ahead of Fedora a little bit, maybe?
I wouldn't say that it's fast moving in terms of feature, because you want to have like this stability. So it's really that you will get, because your operating system is immutable. You don't really go on your machine every day and run like a DNF update or whatever. So pretty much what you get every 2 weeks is this set fresh of packages with like security fixes or just bug fixes and things like that. So really the key a key point for Fedora CoreOS is stability and making sure that we don't break the stable stream. So
I think that's most projects, right? Like, to be fair.
Yeah. So it can happen that, for example, when Fedora 33 was released, the stable stream was still on Fedora 32 because we wanted to make sure that the switch when we were switching from a base from Fedora 32 base to Fedora 33 base, everything was rock solid, and that the update would not break people's host and workloads. All right, so another main feature is the provisioning, and this came from CoreOS. So Fedora CoreOS uses Ignition, which is a provisioning system, and pretty much you have like you declare everything that you want to configure on your host, and this is run at the first boot of the machine in the initram FS, and we just configure the host with like, for example, the user, SSH keys if you want, or like how the partitioning is done and things like that. And yeah, where maybe for people that are a bit more used to the RPM world and all that, and like where you would have used in the past a Kickstart or a cloud init for cloud, you now use Ignition, and got a bit more details here. So Ignition is itself, the configuration is a JSON document, and so yeah, it runs once when you first boot your instances, and it runs in the initram FS when you configure the machine. And here I was giving some example about users, but yeah, you can create files, system units, configure user groups, partitions, create RHEL arrays, format file system. So you can do a lot of configuration there, and just tune your node or your server. Yeah, and if the provisioning fails, the boot fails. So this is something that has to work, otherwise there is no point to boot in a system that would be half provisioned or half configured. And yeah, the point of the configuration for Ignition is it's to be easily consumed by machine, and this is usually not necessarily a good thing for humans. So JSON is not super easy to work with as human beings and to modify. So we have a tool called Fedora CoreOS Config Transpiler, FCCT, that allow you to write your Ignition configuration in YAML in something that is a bit more human friendly, and this will transpile the YAML to JSON. So you can keep your YAML file with all your configuration in Git, and just transpile this to JSON before applying it to your node. All right. Timothée, you want to take the next one? Yeah, go on.
There was a question about why JSON, and I am basically answering in chat like this is designed to talk to machines. So lightweight JSON is better for this than a YAML or God forbid XML. So if you're editing the ignition files by hand, that's like an anti-pattern, I feel like sometimes, right?
Yeah, so yeah, you don't want to touch the JSON file. You really need to use the FCCT and and it's also a good way to force having this every change you make, you commit it to your Git repository. You don't really want to act quickly, make a change quickly in your JSON file, run the provisioning and forget about it.
Yeah,
you want to go through making the change in your YAML configuration, commit it to Git, and have some type of CI, and maybe your CI is actually doing the transpiling from YAML to JSON, and even the provisioning. So it was made to be kind of GitOps, very GitOps oriented, and making sure that every changes you make are stored and tracked in your configuration in your Git repository.
So FCCT is that human to machine interface, basically, right?
Yeah.
Yeah.
I think we had plans to have a web service that does that also. Currently, it's still just a CLI tool. But if anyone is interested, or if we have the time, that might become just a small web service.
There's a Docker image somewhere, or container image somewhere to run this as a container as a web service, but it's not on any official server yet.
Yeah, Timothée, if you want to take the next few slides.
Yeah, sure. So yeah, Fedora CoreOS is definitely cloud native and container focused. That's where we are, and that's where we want to still be in the future. And so if you want to run anything on Fedora CoreOS, basically you will have to run this in containers. You will have to run all your software in containers. So we have both Podman and Moby, the Moby engine, which is usually known as Docker, to run containers. So we support everything. And the OS itself is really made for cluster deployments. So you can either run just one instance of Fedora CoreOS by itself, that works perfectly. But if you want to spin up like 100 nodes at the same time and have them join themselves in a two-end cluster, that's perfectly fine too. And you can do that. And that's where Ignition itself shows its power, because you can automatically have every node that boots up join the cluster and form a big computer by itself. So yeah, when you don't need nodes, you just shut them down and you let them go away. And if you have a lot of user traffic and you need more power, more CPU, and more memory, then you can go again and spin up new nodes. That will be provisioned with Ignition. So Fedora CoreOS itself, we support a lot of the cloud and cloud providers and a lot of platforms. Here we have a list of the most popular ones that we have. But essentially, we are QEMU KVM compatible, so you can run that on almost everything, provided that you can give it an Ignition config. So yeah, mostly supported almost everywhere. Not yet, but we're still working on it. Yeah, go ahead. So yeah, versioning. We have a strong focus on security and on doing things correctly. The idea behind Fedora CoreOS, so we use RPM OS3. The mechanism, the way RPM OS3 works is like Git for your operating system. So it's as if you were going from one version to another of the operating system with RPM OS3, just like you would go from one version of your code to the other with Git. So instead, you still have hashes, but you also have version numbers, which are like a little bit easier to manage. Yeah, essentially, when you get one specific version of Fedora CoreOS, it's one hashes, and then with this hash, you are absolutely sure that what's in this image is the same as everybody else, and you just get the same version as everybody else. So as you cannot go and change everything on the system because you still want to make sure that all your nodes have the same content, then this means that most of the file system is read-only. So /user mostly is read-only, and that's a really good thing to have, because you don't want things breaking up by inadvertence or by mistake, and you want to make sure that all the state of your system is stored in /var, and that you just keep it there, all the containers, all the data, everything that you want to have on your Fedora CoreOS instance be there, and you still have /etc if you want some configuration for the software. And finally, the last nail in the security features is Linux, which is enforcing by default on Fedora CoreOS, just like every Fedora distribution, and which really offers a strong protection for and isolation for containers on the system. So that's like the strongest isolation that you can get by default.
Nice.
So what do we actually have in the OS shipped with Fedora CoreOS? Well, the main thing to remember is that we ship Fedora. We ship Fedora RPMs. So we ship the same content, or almost 99% of the same content as Fedora RPMs. So if it works on Fedora, this will work on Fedora CoreOS. And if this works, if this works in the Fedora CoreOS kernel, this will work on Fedora CoreOS, and so the hardware support is the same, the one as Fedora, as classic Fedora, and everything like that. So yeah, it's Fedora. Fedora CoreOS is Fedora, and we ship a lot of like common tools that you want as an admin, so hardware, some hardware specific tools, and some user management and things like that. The two main container engines, and the only interpreter that we ship is Bash, and we don't ship anything else. So we don't ship Python, we don't ship Perl. So that's like a big difference from most other minimal containers.
Is there even a compiler installed?
There's no compiler installed. So if
Beautiful.
you want to run
a
compiler, yeah, you need a container image to do that.
Everything by containers.
Everything by container.
Someone just commented, we don't need BusyPox either to run a container. Yeah, that's a good point.
Yeah. And
there was, just real quick, I don't know if either one of you know the story behind it, but used to be in DigitalOcean, you could go tinker with Fedora CoreOS. Now I see that it's gone, but then I went to the CoreOS page and I found an image for it. Is that kind of our strategy going forward, is just to make images for certain clouds as opposed to like having this deeply nested, integrated console kind of deal? If you don't know, that's fine. I can figure out the answer from someone else, like a product manager or somebody.
I think it's work in progress on DigitalOcean.
Okay.
It's we do ship images, and you should be able to easily spin them up on DigitalOcean. And I don't remember exactly the status of our collaboration with them regarding that, but I think it's still work in progress.
That might be
cool.
For the,
I will dig.
Maybe for the interface to have like the support for ignition and things like that. Well,
sure. Yeah. I got it. I will dig. Detective Conan Kudo in chat. I will actually text message a PM on the Fedora team right now. How about that?
Yeah, well, this should work because Dusty is running OKD on DigitalOcean, and OKD is Fedora CoreOS based, so there's like no reason this doesn't work. But yeah, I don't know the specifics.
No worries, I will figure it out and I will get an answer. Please continue.
Yeah, sure. So that's perfectly on topic, because what we have coming next is more cloud platforms. So yeah, nice. More collaborations with more cloud providers. We already have a bunch, but we're always adding more. And we're also trying to improve our state on running. Clement, you're not focusing anymore.
Sorry.
Uh-oh. The joys of screen
should
sharing.
Be back.
Yeah, you're back. It's good. So yeah, we're also working on multi-arch support, on better multi-arch support, because currently we're only running on x86, which is like a lot of the workload, but we want to move that forward, especially on IARch 64.
I got a box of Raspberry Pis just waiting to be
just
put together for containers. Yeah.
You'll still need like something that has basic like SBBR or some ARM standards for boot up, for bring up, because we it's hard to support every single ARM sock out there, but if you've got like standard ARM, this will work. So I don't know about the support for Raspberry Pi, but this is work in progress.
Nice. Okay, cool. Yeah, I'm not too worried about Raspberry Pis as more and more things come about, right? Like the ARM architectures we should focus on are those server-based ones first, obviously. Not necessarily for my pleasure, but yes.
Yeah. Well, it's the server ones are a little bit easier to work on because they boot in a standard way, and that's easier to support. And next we also have some more FCCT sugar, as we call it. So it's more friendly helpers to help you write ignition configs in a more straightforward way with FCCT. So FCCT is YAML. That's the one that you should write, and we want to have that being as friendly as possible, so that when you write some config, you don't feel like you're slowed down by the format.
Nice.
For a while we had issues with adding more packages on top. Well, not issues, but like limitations, and most of those has been resolved. But we still want to move forward on that. So Fedora CoreOS by itself is immutable. You don't change the host. You don't change the set of packages installed. But even if it's not like suggested, you still can do it, because RPM3 is capable. He knows how to do that, so you can still add packages on top of that, and it's safe. And we want to improve on that. So we did a lot of work to make that work and work reliably for updates, and we are still working on that to make this even more reliable and like even more supported. Documentation too. We want to improve our documentation. We have a good bunch of documentations. If you go on the Fedora docs, you can see a Fedora CoreOS section and a lot of docs on how to deploy on each platforms and how to work with Ignition and how to write configs, a lot of storage and everything related. And we'll show some part of it. And finally, some work on OKD. So OKD, I think it's the next slide. If you could move on, we'll talk about that pretty soon. So yeah, what's like? Okay, we have Fedora CoreOS, and there's also RHEL CoreOS. So what's like the difference? What are the relations? So the idea is they share a lot of the tools. We share a lot of the tools that we use to build them and both, and they're the same mostly. The idea is that the main difference is that RHEL CoreOS is not intended as something that you use alone by itself. So instead of being based on Fedora RPMs, it's based on RHEL RPMs. And it's mostly a component of OpenShift. So you don't run RHEL CoreOS by itself. You run them as part of an OpenShift cluster. And the difference here is that all the configuration and the updates are managed by the cluster itself via operators. So that's basics of OpenShift and the relationship with RCOS. Fedora is an host by itself. So it's based on Fedora packages. And even though we share all the toolings, the updates are standalone. Each and every single node updates by itself. You can still like have them being part of a cluster and share the update mechanism, but it's not enforced. It's not enforced by the system. So yeah. Go ahead. Yeah. So OKD. So OKD is basically OpenShift on Fedora CoreOS. Or well, maybe I'll get it's close to being OpenShift on Fedora CoreOS. So the idea is that you use the same kind of installer. It's OpenShift install, and you will get the upstream bits of OpenShift directly running on Fedora CoreOS, and everything there is operator controlled. So it's controlled by the cluster. You get get something really similar to what OpenShift is, but based on Fedora CoreOS itself. So the updates are managed the same way. They are cluster managed, and the nodes reboot one at a time and one after the other, and not everybody at the same time. And the cluster is capable of bringing up machines automatically if you need more power, more CPU, more memory. So that's basically OKD. We'll have a short demo for OKD if people are interested.
Cool.
So yeah, that's
where to get involved.
Yeah, that's where we are. So if you want to go forward with that, if you're interested, you can get Fedora CoreOS on the getfedora.org website. We have an issue tracker, dedicated repo on GitHub to track issues, and of course we discuss. We also available on the forum. We have a mailing list and RC channel, and we'll be talking about Fedora CoreOS. We've been giving a short workshop, a hands-on lab during DevConf, so that's at the end of the week. If you want to go over there and meet us there. Yeah, DevConf is virtual this year, so everybody can join in.
Yeah, it's going to be cool.
Yeah. And I'll be doing the hands-on lab, so you'll see me there.
Awesome.
It's really a good opportunity to have a kind of a first experience with Fedora CoreOS and play a bit with it.
Yeah, and the slides are on our speaker deck page, folks. I just dropped the link in chat. So if you want to pull up the slide and click at the links individually, feel free.
All right, time for some demo. So,
yeah. Let's go. Go ahead, Clement.
Yeah, so the small demonstration we have today is pretty much showing how to run like a matrix server on the Fedora CoreOS host. So we have like this simple diagram that kind of show you how the server and all the services are configured. So as the base, you have like Fedora CoreOS that provides all the kernel, SC Linux, all the networking stack, and a container manager. So in that case, we use Podman. And so Podman is running different services, and all those are configured as systemd services. So when the host boots, those systemd services will start the Podman pods and the different Podman containers. So we're making use of the pod feature of Podman to have like a shared network between each services. So it makes it very easy to configure and very easy for each containers to talk to each other. So they just assume they're on the same network. You can use like local host. And we have also like some volumes to store like the data and configuration and things like that. So you don't have like to be necessarily a big expert into how the matrix server works, but pretty much you have like Synapse, which is like the server that implements the matrix protocol. Database element is the web client. Then you have Nginx as a web server in front of it. And we have like a small Nginx server that you can use to automate the configuration of getting the certificates for HTTPS and having let's encrypt provide certificates. So we can use HTTPS.
I love Let's Encrypt. It's like the most unthought of, most needed service ever, right? Like,
yeah, it's super
we need an
useful
easy way to get everybody secure.
Yeah.
Thank you, EFF. We really appreciate you.
It gives you no excuses to not use HTTPS.
Yeah, like my cluster here, I every time I have to like redo it or whatever because I destroyed it during a demo or something. Yeah, like that's step one after getting it installed and up and running is get rid of the certificate errors. It's just an annoyance that I can get rid of. So why not?
Yeah. So we talked a lot about FCCT, and here it's an example of this YAML file. So you will have like the version, for example, how to configure a user and give like some SSH key. So here it's using some templating. By the way, there is the link to that repo in the slide, and if you want to have a look, there is a README where you can follow the instruction and pretty much run that and run your own metric server based on Fedora CoreOS.
Yeah, I just dropped that in the chat here. So folks, please, if you
feel
we have like kicking the tires, go ahead.
Yeah. Here we just have like a small service that configures cgroups v2 because they are not yet enabled by default in Fedora CoreOS. We just still use cgroup v1. And then you have like what we are talking about, like, so for example, creating a podmat pod and starting different services. So it's, if you're familiar with Podman or even like Docker or any container engines, is fairly common commons where you would give a name, like share some environment variable, some volumes, and things like that. So pretty much declare all your services. And those will be provisioned and configured and run at the first boot of the machine. Here we have like a nice little service that will renew the Let's Encrypt certificates. I think it's checking pretty much every week on Sunday. It's running Certbot to make sure that that our certificates are still valid. So that way you don't wake up one morning and say, "Oh, I forgot to update the certificates."
It's done.
And some examples on how you like create directories on your host and how you can copy some configuration files. So, for example, all the Nginx configuration or the configuration for Synapse or Postgres, something like that. So that gives you kind of an idea of what is FCCT, and so this is then transpiled into JSON. So, but Timothée, maybe you want to show that part. So I'll stop my screen, and if you want to share yours.
Yeah, I'll do the next one. So here, how's that?
A terminal, my favorite place. Everything is so simpler feeling.
Yeah, so the idea is here, so everything is in the repo. So here it's just a clone of the repo where I've just set some secrets, some variables, some secrets to configure the instance that we are going to create, because essentially what we have is like this configuration is enough to start an instance by yourself and run it. So you have the config, the main config, which is the YAML, and we just have a short make file to do some substitutions. So replacing all the secrets value with the one in the config. And if you just go and do that, and if you just like do that inside my toolbox, that will work better. That will be it. And you will get essentially you will get an ignition config. So that's the last part here. It's a call to FCCT that will pass all the YAML and will give you an ignition config that you can give to a virtual machine, a Fedora CoreOS instance. So if I just take a look at for the config, for example, here it's like awful. You cannot even really read it because it's really messy. It's really big and it has a lot of compressed data because we have all the configuration inside it. So it's not really readable because what we want to read, it's this one. It's a YAML here, which is clearly readable with all the data that we want. So yeah, once you have this configuration file, you can go ahead and use your preferred cloud providers, your favorite cloud providers, and spin up a VM virtual machine and have it automatically start a Fedora CoreOS instance and everything to host a matrix server. So here, that's what I did just this morning. And if I just go and SSH to machine, here we go. That's what I have here. So if I just run an OperaMS3 status here, we can see that I'm running Fedora CoreOS, the latest version, the latest stable version here. And that's it.
Awesome.
So what do we have?
That's it.
What do we have running? Then, because, well, having a system is good, but like if you can't run anything, that's not great.
That's not good. Yeah.
Yeah. So here are the containers. So they have been automatically deployed by Ignition. The configuration has been written, and then the system just booted up and started everything. So I did almost nothing on the system after that. And here we have Synapse, we have Nginx, Postgre, and everything running just like we shared before. So yeah, you can actually try that live. So I've deployed that live on something that is running. So if you go to, I'll just stop sharing this screen and share another one.
Sweet.
If you go here, so if you go on chat.fcos.fr, you can go ahead and register yourself. So it's a fully running instance of Matrix that is federated with the rest of the ecosystem. So if you already have a Matrix account somewhere on another server, you can reach out to me. You can create yourself an account here. Of course, the instance will be destroyed at the end of the day, so don't make that your permanent account. That won't work. And once you've created that, you can log in. So I'll just log in with mine here that I just created. And you can send me a message. And that should work. Yeah, just forget about security. We'll do that later. Here we go.
The nice thing it's that pretty much having this FCCT config or the Ignition configuration and knowing that the host is able to be provisioned and to run that, it gives you kind of a very easy way to ship software pretty much. You just don't to ship your individual containers, but you can start to think about like just releasing the OS with all the service running and everything configured directly as one configuration file. So that's
awesome.
That's quite powerful, I think, for services where you have like a lot of moving component and moving services.
Yes,
very cool.
It's really a high. Like something like it takes some bit of effort first because you have to write everything down in the config. But once you've done that, it's really, really high value because this one here, we did this one a while back for an article and we deployed it. So it took us a while to make the config. But this one, I just deployed the machine this morning. And it was like 5 minutes, the time the machine boot up, and you're done. And that's it. And
wow.
Nothing has changed in the config. And like, so it's really, really highly valuable when you want to boot a lot of instances or when you want to do that frequently. Because if you do the work once and then you reap all the rewards every time you do it. And it's really powerful.
That's awesome.
You can forget about it, and the box will be updated. You get the latest updates. It's pretty cool.
Yeah. So yeah, that's another one of the features that's important here for this deployment is that you know that this will keep the machine properly running and up to date with latest features, because as we auto update the OS, we also auto update all the containers
on
restarts.
Nice.
So if you just leave it running, that's going to be fine, because you will just like every 2 weeks the host will reboot for dates, and then you will get all the latest versions of the containers. And if for whatever reason something happens and that, let's say another version or some version of Postgres does not work anymore, then that's perfectly fine. You just go back to the previous one and you move on with your life while people get time to fix the bugs.
Nice.
And that's it. You check again in 2 weeks, and yeah, you report bugs. You check again in 2 weeks, and things move on. And that's like the power of containers with other updates and everything plugged in at the same time.
So Carlos Santana, who happens to work at IBM, is on the channel right now, and he's wondering if there's like a Knative thing that you could do with these systems potentially, right? Like an HTTP gateway to be able to start containers based on requests or scale to 0, that kind of thing. Any kind of serverless or functions that we can do with Fedora CoreOS kind of out of the box, just as long as we have the container, it should work, right? Maybe.
I think you could probably, but you would have like to pretty much write the glue that does the orchestration and spinning up the more VMs if you need, anything like that.
You would. Yeah, like that. There would have to be something on top, right? Like, yeah, you would want like Kubernetes essentially. So that kind of leads me to my next question: is how do you go from FCOS to OKD or just vanilla Kubernetes, however you want to describe it, right? Like, is it as simple as just saying, I want OKD and I get FCOS as part of that? Or is it something that I can build up together as to kind of like cut my teeth on it kind of deal?
You'll have to go straight to OKD. So there's no really middle ground between Fedora CoreOS and OKD. Well, you can roll your own Kubernetes on top of Fedora CoreOS,
right?
That's perfectly fine. You have distributions such as Typhoon, for example, that automate all the bring up of a vanilla Kubernetes cluster on top of Fedora CoreOS, and that works great. And it's using Terraform, so that's support for got a lot of support for all the cloud providers. But yeah, so and on the end of the spectrum, you have OKD, which in a sense you don't see Fedora CoreOS in OKD because it's hidden in the layers.
Right.
And
you don't
just
see it.
deploy your cluster, and Fedora CoreOS is just underneath there.
I think to me is really the difference is really the scale and the number of VMs you want to deal with. If you have a relatively small shop and you have, I don't know, 20, 30 kinds of VMs, and you don't really want to get the complexity that comes with Kubernetes, probably having Fedora CoreOS is a good idea, and like having some way to orchestrate that with like a small number of nodes. If you start to go into something bigger, it's Kubernetes is more.
Yeah, exactly. Right. Like that's exactly why Kubernetes exists.
Yeah. So if you really need to scale at the big numbers, yeah, it's good to go directly to Kubernetes, OKD, or OpenShift. If you have like a small infrastructure with like some small services that you kind of want them to be low maintenance and not really care about them, FCOS I think is a very good candidate.
Yeah, I like FCOS for tinkering, right? Like I just want to throw a container on something, off I go kind of deal. And
yeah, I think this is also, for me, it has a lot of value also in kind of this DevOps pipeline where
totally, right? Like throw it in your CI/CD really pipeline and just let it rip.
Yeah. And instead of thinking about just your application as a container, suddenly you can test all your services, your OS, and you have like this all stack pretty much together. And you can almost develop your application, integrate everything in Fedora CoreOS, and deploy that directly to production and have like kind of continuous delivery where you run your test and your CI on the OS that will be running in production.
Yeah, so someone's asking what's like the minimal, like, you know, hardware specs, I guess, for FCOS, right? Like, what do you need kind of out of the box maybe to just run the OS?
So the reasonable, like low requirements are something like 2 gigs or 3 gigs, depending on how you do the installation. If you do it on live PXE, you will need 3. If you do it on cloud platforms, you can go with 2, and that should work.
Okay.
Of course, that's only if you want to run only really small containers. Because if you want to start like a really big Postgres database, you will need more memory.
Exactly.
Sure.
Yeah. I mean, that bare minimum line though is a good, you know, like bar, right? Like, you know, you need that 2 gigs plus whatever you're running on top of it. So you really can, in a more simplistic way, kind of be like, okay, well, I know this container is going to be a database and it's going to hold about 16 gigs. So I need, you know, 24 gigs of RAM just to make sure everything works right.
That's the basics. And on the disk footprint, you need at least 5 gigs. So let's say 6 gigs, 8 gigs is good if you want to be conservative. Other ways, the more the better. But,
right. Yeah. You know, I mean, you can easily run this on your local machine with Podman kind of deal. Is, you know, as long as you can get a container going, you'll be good. All right. I think that wraps up all the questions. Yes, it is a smaller footprint than CRC, but it is just the OS and just the tools to run containers. It's not the whole kit and caboodle with all the operators and everything. But if you want to get your hands on a developer sandbox for OpenShift, those are available now, and those are ephemeral. I think they rotate every 2 weeks, I think, right now. So you can definitely fully kick your tires on OpenShift for free, essentially, right? Like, just log in with a developer.redhat.com account and off you go. So yeah, thank you, Timothée. Thank you, Clement. This was great. A lot of people, a lot of questions, right? Like, that's always a good sign of a good show. So thank you very much for coming on and showing this off. And I would love to have more, you know, FCOS related things in the future if you can sometime. How about that?
Yeah, sounds good.
That would be good.
Like a
awesome
challenge.
Yeah, great.
We'll have to write a new example with all the services.
Yeah, whatever service comes next, right? Like, just start adding on to it, right? Like Matrix, or IRC, you know, just keep going.
I think maybe having some CI runners or thing like that, like GitLab CI or thing like this would be interesting.
Full GitLab installation on Fedora CoreOS.
There you go. Why not? Come on. And then you put Quay on top of that, and, you know, everything else. All right. Well, thank you so much. Thank you, everybody out there, for watching. We will be back on the air here in about an hour with our developer experience office hours. We're going to be talking about Odo scenarios, like when to use Odo, that kind of thing. So please stay tuned. You know, it's an office hour, so you can bring your questions too. Feel free. And until then, stay safe out there, folks. Thank y'all.
Bye, everyone. Thanks, Chris.